Hello everyone, welcome to my channel oneconceptelectrical. Here one of the DC series motor question. In this question, the mainly concept is based on what is developed, what is developed torque, what is a shaft torque. Here in this question they are asking to find developed torque and shaft torque. We should mainly know what is the difference between shaft torque and developed torque. Let's solve this question. Here it is given a 4-pole DC series motor. It is a wave connected winding. Wave connected winding means number of parallel paths will be 2 and number of connectors is 600. Means number of connectors Z equal to 600. And total resistance of motor means armature resistance plus series field resistance will be 0.8 ohm. It is feeding its power feeding from a voltage source of 250 volts means a terminal voltage of 250 volts. And a motor supplies a load of 10 kilowatt. Here the motor supplying a load of 10 kilowatt means it is the power in the shaft means P shaft is 10 kilowatt and it takes 50 amps current from terminal voltage means the load current will be 50 amps and flux per pole is 3 Weber and they are asking to find developer torque and shaft torque. Okay, let's write down the data here. Here it is given number of poles equal to 4 and output power means shaft power of 10 kilowatt and number of parallel paths equal to 2 because of wave winding. Number of armature connectors is 600 and armature resistance of 0.8 ohm and terminal voltage of 250 volts and drawing a load current of 50 amps and flux of 3 milliweber. With these conditions, we can able to find back EMF of the motor. Back EMF of the motor is EB equal to VT minus IARA. By substituting the formula, I found a back EMF of 210 volts. After knowing back EMF, we can able to find what is the speed of this motor is running. By using the formula back EMF equal to Z by A into P into pi into N by 60. Here Z is number of conductors, A is a parallel path, P is a number of poles, pi is flux per pole, N is speed in RPM, E is a back EMF. By substituting all the data here, I found the speed of the motor is 3500 RPM. Here we need to know power developed is power developed by motor equal to P shaft plus rotational losses. Means if power developed by motor, it will transmit power to shaft plus it will compensate some losses as well like frictional losses. Here shaft torque means the motor rotating shaft which will couple to some load it will deliver shaft power to particular load. If shaft power plus rotational losses means P frictional, it will be developed power. They already given output power of 10 kilowatt. We can able to find shaft torque by P shaft equal to P out by omega. Omega is in radian per second. Omega is in radian per second minus 2 pi ns by 60. By substituting this formula, the shaft torque is 27.29 Newton meter. The developed torque is EB into IA means is in developed power. It is in developed power divided by respective speed in radian per second. By substituting this formula, we can able to find the developed torque is 28.66 Newton meter. Here we see always the torque developed will be more than T shaft because in between there will be some frictional losses. If you add frictional losses into T shaft, it will become T developed. This torque developed. This is a basic question. In order to solve this sort of question, please subscribe to my channel.